Good day, viewers. Dauda Malik is my name, and I'm your tutor this afternoon. In today's section, we are going to treat confidence interval. So, with confidence interval, we have large samples and small samples. So, to start with, we are going to start with the large samples, that's for Z, and the small samples is for T, normally called the T distribution. So, with confidence interval, I must have my tables here. So this is my standard normal table for the small, like for the large sample, that's for Z, and this is my T distribution for the small sample, that's T table. So to start with confidence interval, we have something we call critical values. So we have to find the critical values before we can start the session. So this is my distribution. This is on my left side, this is on my right side. So this is on the left of Z, this is on the right of Z. In between here is called my level of confidence. Yeah, and we have a formula here that's half of 1 minus C. The C is the confidence level. The same thing applies to the left side. So if I said I'm 95% confident that I'll pass this examination, it means my C here is 95%. So I will use examples so that we will find the critical values. So this thing here is called the critical values. So assuming, for instance, 95% confidence. With 95% confidence interval, it means we will send this 95 into a decimal and we place the decimal here. So 95% to decimal is 95 over 100, which is 0.95. So if you want to find the critical values for 95% confidence interval, this is the formula. So it will be half times brackets 1 minus 0.95. 0.95. So you use a calculator, then you point this one there. So half 0.5 times bracket 1 minus 0.95. Bracket close. So this is how you point this on a calculator. So you point half times 1 minus the level of confidence. This is the level of confidence, and the level of confidence here is what? 95%. So with this 95%, we send it to decimal and we put it here. So when I press equal to, I got 0.025. So with this, with 95% confidence interval, I got 0.025. So this represents my Z. That's what, my Z. So my Z is 0.025. When you got this one, you are not done. You have to go to your standard normal table to find 0.025 on the table. So when you find with this, we are finding it within the table. So when you find this 0.025, that's this area within the table, then you look at which number on your vertical axis and which number on your horizontal axis come together to form what? To form this 0.025. So with 0.025, you have to go to the negative side of the table. So this is my zero column. So 0.025 is here. That is 0.02500. So it can be located here, this side. So when I look here, it's what? Negative 1.9. And here is 0.6. So 0.025 on the table is negative 1.96. So here on the table is negative 1.96. It means this side is negative 1.96. And because this is positive side, it's what? It will be 1.96. So 95% confidence interval, 95% is equal to 1.96. Here too is 1.96. So my Z of confidence for 95% confidence interval is 1.96. So this is the formula. First of all, you change the percentage to decimal. Then you put it here where we have the C. The C represents the level of confidence. So when you input this on a calculator, the answer that you get, then you go to the table and find it there. So the area of 0.025 on the table corresponds to 1.96 Z score. So here my Z, C, that's Z of confidence. Z of confidence is equal to 1.96. So this critical values here for the Z of C, that's Z confidence, is 1.96. So anytime you are given 95% confidence interval, it corresponds to a Z of 1.96. So to make it easy for you, I have solved for the rest. So anytime you are given a 90% confidence interval, so 90% correspond to 1.645 Z. 95% correspond to 1.96. 98% correspond to 2.33, and 99% correspond to 2.53. Sorry, 2.58. Okay. So anytime you are given a confidence level of 90%, don't waste your time to solve it. Or you can even solve confirm that it's 1.645 or 1.65. So anytime you are giving a 95% confidence level, it's 1.96. And I just solved, and now you know that I'm correct. So that's how we find the critical values. So anytime a question is given and the confidence level is, let's say, 90% confidence interval, it means you have to divide the 90 by 100, then you get 0.90. Then you substitute the 0.90 to where you have the C here. So when you input this formula on the calculator, the answer that you get, then you find it within this table. When you get the answer, then you look at which number on the vertical axis and which number on the horizontal axis comes together to find or to form that area that you've gotten on the table. So that's how we find the critical values. Thank you. Okay. So under confidence interval 2, we have something we call margin of error. With the margin of error, it's a formula that we use to calculate the confidence interval. And the formula states that since we are using Z, that's for large samples, what will make you use large samples is that there's a property here. Always your N should be greater than or equal to 30. So when the sample size in the question is greater than or equal to 30, it means you are dealing with large samples. So that's where we use the Z. Okay. And the formula of margin error says that E is equal to, that's margin of error is equal to Z of C times standard deviation over root of N. And you see, this formula alone is called the standard error. This alone is called the standard error. So Z of confidence, that's what we did, then the standard error. Okay. So this is the formula for margin of error. So let me clean the standard error. Okay. I just explained it to you so that you know that it's standard error. Okay. So we are done. So this is the formula for margin of error. And with the margin of error, we have an interpretation of the margin of error. Because whenever you are solving for confidence interval, you have to get two answers. One on your left side and one on your right side. So it's through the interpretation of the margin of error that helps us understand the answers given or derived for the confidence interval. So when you are interpreting your answer for the confidence interval, this is the interpretation. Okay, so the interpretation that is So when you've done solving for your margin of error, this is the interpretation. This is the mean. So in the question, they will give you a mean. So when you are calculating for your answers or for your z, the mean will be there. The mean will be left untouched. So when you get your answer for the margin of error, including a confidence interval, then you subtract the margin of error from the mean on your left. Then you add the margin of error to the mean on your right. So you see, after you are done with your confidence interval, you have to get two answers. So this is the interpretation of the margin of error for your confidence interval answers. So you are going to solve a question. I know it might seem confusing, but when you solve the question, I know it will be very easy for us all. So let me read the question so that we can solve them. Okay, so please, I'm coming to read the question out so that we can all solve the question. Okay, so there's a question here. Listen to the question. A random sample of 42 textbooks. A random sample of 42 textbooks has a mean price of 114.50. So a random sample of 42 textbooks. A random sample of 42 textbooks. So our n is 42. A random sample of 42 textbooks has a mean price of, so the mean, that's S bar, is equal to 114.50 and a standard deviation of 12.30. So the standard deviation is 12.30. Okay. Full stop. He said find a 98% confidence interval for the mean price of all textbooks. So we are finding a 98% confidence interval. So the CI, confidence interval is what? 98% confidence interval. Okay. So this is the question. So solving for this question. First of all, we have to find the critical values of the for the 98% confidence interval. So to find for the critical values, the formula is half brackets 1 minus C, where the C represents the level of confidence, and the level of confidence here is 98%. So we have to change this 98 to decimal. So it will be what? 98 over 100. We get 0.98. So 0.98, then we put the 0.98 here. So it will be half bracket 1 minus 0.98. So if you input this on a calculator, our final answer will be 0.025. So with this 0.025, then you take your standard normal table to find this 0.025 on the standard normal table. So with the 0.025, it's here, and it corresponds to a z-score of what? 1.96. So 1.9 on my vertical axis and 0.6 on my horizontal axis. So this one corresponds to a z-score of 1.96. So it means I've gotten my what? My critical value for the 98% confidence interval. Now, I just have to substitute these figures into the formula, then I'll get my answer. So the margin of error said that. So please, I hope you've gotten these steps. Okay, let's come here. The margin of error said that E equals Z of C times standard deviation over root of n. So this is the margin of error formula. Now, we've calculated for the confidence level and we got a z-score of 1.96. So where you find the Z of C, we put the 1.96 there. So it will be margin of error, that's E is equal to 1.96 times the standard deviation in the question is 12.30 times 12.30 over root of n. The n is what? N is 42. So 42. And you see here, our n is greater than 30. So it means we are using what? The large samples, that's the Z. So whenever your n is greater than 30, whenever your n is greater than 30 or equal to 30, it means you are using what? The large samples, and the large sample is the z. So now this is the formula. You just pick your calculator, then you point this one there. So 1.96 times 1.96 times, okay, 12.30, that's our standard deviation, 12.30. Okay, so root of 42, okay, 42. So on my calculator, I got 3.71. So all this one, my margin of error is equal to 3.71. So this is my final answer, 3.71. Okay. So 42, 12.30, then what? 98% confidence level. Okay. So after I finish everything, I got 3.71. Okay, so I can run this one to make it 3.72. Okay, 3.72 like this. So when I'm done, I've gotten 3.72 as my margin of error. And I said that with confidence interval, we had two answers, one on your right and one on your left. It means I have to interpret this answer. So with the interpretation is where we have x bar minus e less than mu less than x bar minus e. So the x bar is the mean in the question. So as I told you, when you are solving for confidence interval, they will give you a mean, but you not use the mean in the calculation. After you find your margin of error, then you subtract the margin of error from the mean on your left side, then you add the margin of error to the mean on your right side. So this is the interpretation. So my mean is 114.50. So 114.50 minus the e. My margin of error is what? 3.72. So less than mu, less than the same mean. So my mean again is what? 114.50. So here is what? Is plus. So you subtract on your left, then you add to the right. So plus the same margin of error, 3.172. So when you are done, then you take a calculator, then you point. So 114.50 minus 3.72. So I got 110.78 less than mu less than. So here we add. Okay. So here too, I got 118.22. So this becomes my final answer. So this is how to solve for confidence interval for large samples. I know it's not difficult. So in the question, they will give you a mean. You will not use the mean to calculate. After you solve for your margin of error, then you subtract the margin of error from the mean on your left side. Then you add the margin of error to the mean on your right side. You are done. So that's how to solve for confidence interval for large sample. That's Z. Please, I hope you're okay. Okay. Then let's solve another example. Then we see. Okay. So with this example, we said a random sample of 50. A random sample of 50. Okay. So a random sample of 50 students are in a class. A random sample of 50 students are in a class. And the confidence level is 95. The confidence level is 95. So my n was 50. My confidence level, is 95%. My standard deviation is 5.0, and my mean is 12.4. Okay. So this is the question. I have summarized the question so that we can go what on time. So my n is 50, my confidence level is 95. So first of all, you have to find the critical values. That's what half bracket 1 minus c. So we have to change this 95 to decimal. So 95 over 100, we get 0.95. So 0.95, then we substitute it here. So 1 minus 0.95. So we get 0.025. It's the same thing. So this 0.025 on the table, this 0.025 on the table is 1.96. So your Z of C is 1.96. Please, I hope we are okay. Yeah. So assuming the confidence level was 98%, 98%, it means it will what? 98 over 100. So we get what? 0.98. So in place of 0.95, we place what? 0.98 here. So with the 0.98, we take your calculator, then you point 0.5 times bracket 1 minus 0.98 bracket close equal to, so I got 0.01. So with 98% confidence interval, I got 0.01. Then you go to your standard normal table to find 0.01 on your standard normal table. So 0.01 on my standard normal table is here. Okay, so you find here, so you see we have column here. So 0.01 can be find here. So this side, so it's 2.33. So 0.01 on my table, we have negative 2.3 here, and we have 0.03 here. So it comes together to form what? So it's here like this. So 2.33. So this is 2.33. So my Z of C for 98% confidence interval is 2.33. So always, I'm going to list it on the board as I said earlier on. Whenever you are given a 90% confidence interval, 90%, your Z of C is 1.65. Whenever you are given a 95% confidence interval, your Z of C is 1.96. Whenever you are given a 98% confidence interval, your Z of C is 2.33. So don't waste your time to solve it. I know you've learned how to solve them, so you can solve and verify if it's true or false. So right now I have my Z to what? 2.33. So I'll just go and put it into the margin of error here. So you come here, then E equal to Z of C. And my Z of C for the 98% confidence interval is 2.33. So 2.33 times standard deviation. Standard deviation here is 5.0. So 5.0 over root of n. My n is what? Is 50. So 50. So you take your calculator, and as usual, you point it. So 2.33 times then 5.0 root of 50. So root 50. So my final answer here is 1.64. 1.64. So my E is equal to 1.65. I'll round the 7, so 1.65. So this becomes my final answer. I'm saying that when you are done, when you reach here, you are not done. You have to interpret your answer. With the interpretation, you subtract this margin of error from the mean on your left side. Then you add the margin of error to the mean on your right side. So let's interpret it here for us to see. Okay. So with the interpretation, is what? Mean minus margin of error less than mean plus margin of error. So the mean in the question is 12 was 12.4. So 12.4 minus our margin of error was 1.65 less than mean less than the same mean again. That's 12.4 plus the same margin of error 1.65. So when you are done, then you take your calculator, then you what? You add them. You add on your right, then you subtract on your left. So 12.4 minus 1.65. So with this, I got 10.75 less than less than. So I'll add here. You subtract from your left, then you add to the right. Okay. So delete. So when I added, I got 14.05. So this is my final answer. This is the interpretation of the confidence interval. So this is how we solve for confidence interval. So always with the large samples, when your n given the question, when your sample size is more than 30 or 30 from 30 go, it means you use what? The large sample. That's why we use what? The z. So when the n is more than 30 or is 30, we use the z. And when the n is less than 30, that's where we use the t. And we are going to the t right now. Please, I hope you're okay. So this is how we solve for large samples under the confidence interval. That's the z distribution. That's the z confidence. Please, I hope you're okay. Now let's go to the t distribution. Small samples. Okay, so the t distribution is for small samples, and with the t distribution, we have to have our t distribution table. It has its own distinct table that we use for it. So it's the same formula. The formula for t distribution is take the same margin of error, but you see here for the large samples we have zc, that's z confidence. But when it comes to the t distribution, the z will change to t. So it's the same thing. For large samples, we use z. And for small samples, that's the t distribution, we use t. So it's the same thing. But with the t distribution, it has something we call the degrees of freedom. And with the degrees of freedom, that's df. With the degrees of freedom, it says that we subtract 1 from our sample size given. So df is equal to n minus 1. So when they give you a sample size in the question, then you subtract 1 from the sample size to get to degrees of freedom. So when you get to degrees of freedom, plus the confidence level given in the question, then use your t table, then you find it here. It's very simple. We are going to do examples so that you get what I'm trying to say. Okay. So with the t distribution, your n should be less than or equal to 30. So when the sample size given is less than or equal to 30, we use what? The t distribution. So with the t distribution, you always, when you are solving for confidence interval, you have to check the n, the sample size. If the sample size is more than 30, it means you use the z. That's the large samples. And if the sample size is less than 30, that's where we use the t. And always with the z, the population standard deviation is always known. With the z, that's the large samples, the population standard deviation is always known. But here, the population standard deviation is unknown. Okay. So I have a question here. Let me read it out so that we find it. So assuming this question, we said we should find the critical values. That's T of C. Necessary to form a 95% confidence interval with a sample size of, okay, so per this question, you see the sample size here is 15. It means it's less than 30, so we are using the T distribution, and we have to first find our degrees of freedom first. So D solution df is equal to n minus 1. The n in the question is 15, so 15 minus 1, we get what? 14. So our degrees of freedom becomes 14, so our D dot F becomes 14. And the confidence level is 95%. So when you look on the T distribution table, you see we have percentage here. We have from 60 to 99. With the question, the confidence level was 95%. So we have 95% here. That's 95% is here on this side, and our degrees of freedom here is also on this side. That's DF, that's degrees of freedom. With the question, our degrees of freedom was 14. So 14 is here. So you trace from 14 to where we have the 95% confidence level. So the 14 is here, and the 95% confidence level is also here. So when I trace, I got 2.145. So for 95% confidence interval with a sample size of 15, my T of C is 2.145. This is how you get what I was doing. It's not difficult. You'll be given a confidence level, then you're giving what? A sample size. With the T distribution, you have to find your degrees of freedom. You subtract 1 from the sample size to get what? Your actual degrees of freedom. We have the degrees of freedom on this vertical column, and the percentage that the confidence level is on the horizontal column. So my confidence interval was 95. My 95% is here. My degrees of freedom was 14. It's also here. So you trace from the 14 to where we have the 95% confidence interval. The area there becomes your T of confidence. That's what your critical values for 95% confidence interval. So this is how we find the critical values for T distribution. You first find your degrees of freedom. That's what, subtracting 1 from the actual sample size. Then with your table, you find the corresponding degrees of freedom to its confidence level. The area there becomes your answer. So let's solve a question on T distribution as well, and let's see. So I have a question here that I want us to solve it. Okay. Okay. It said a random sample of 15 DVD players. A random sample of 15 DVD players. So it means our N is 15. If our sample size is 15, it means it is less than 30, meaning we have to use the T distribution because the sample size is less than 30. So I read, a random sample of 15 DVD players has a mean price of 64.30. So the mean price is 64.30. And a standard deviation of 5.6. So the standard deviation is what? 5.60. Find a 95% confidence interval. So our confidence interval, is 95%. So we should find a 95% confidence interval for the mean price of all DVD players. So we are finding this. And because our sample size is less than 30, we are using the T distribution. If it was supposed to be more than 30, we would have rather used the Z, that's the large samples. Okay, so first of all, we have to find our degrees of freedom. So our DF is equal to N minus 1. So DF is equal to, N was 15, so 15 minus 1. We got what? 14. So our degrees of freedom here in the question is 14. Now, let's find, and our confidence level is also what? 95. So our degrees of freedom is 14. So we look on the T distribution table. Degrees of freedom here we have 1 to 100. So here, per the question, our degrees of freedom was 14. So 14 is here, and the confidence level was 95%. 95% is also here. So you trace from 14 to where you get 95%. And my T of confidence is 2.145. So here is T of C is 2.145. Now we are done with the table. So you go straight to the question, then you solve them. So because we are done, our degree of freedom was 14 and the confidence level was 95. Its corresponding area was 2.145. So you come here, then you write the same margin of error. So with the margin of error, it becomes what? Our E is equal to T of C times standard deviation over root of n. Our E, that's margin of error, is equal to, the T of C was 2.145. So 2.145 times standard deviation in the question was 5.60. 5.60 over root of n. Our n was what? 15. Then we use our calculator to find the answers. Okay. So 2.145 times 5.60. So 5.60 root of 15.15. So my final answer was our E is equal to 3.10. So this is my margin of error. And I said that with confidence interval, for large samples or for small samples, you have to get two answers. So with the interpretation, you subtract your margin of error from the mean on your left side, then you add your margin of error to the mean on your right side. So it is the same as what? So this minus less than plus. Okay, so the mean in the question was 6.40, so 64.30 minus the E was 3.10, less than our the same mean 64.30 plus, so we subtract on the left, then we add to the right, so plus 3.10. So we take our calculator, then 64.30 minus 3.10. So I got 61.2 less than. So here we add to the right. So I will leave the minus, then plus 3.10. So here too, I got 67.4. So this becomes our final answer. So the final answer was 61.2, comma 67.4. So this is my final answer for my T distribution. So it's not difficult. This is how we find the T distribution. So with the T distribution, you have to always have your T distribution table where we have the degrees of freedom here and the confidence level. So by subtracting 1 from your sample size and getting your degrees of freedom, then go to the table with what? With your corresponding confidence interval that has been given to you in the question. Then look to the area on the table. So when you find the area, then you substitute it into the formula where we have what? The T of C. That's the T of confidence, where we have this one. So after substituting them, then you get your final answer. So this is how we find the T. That's what T distribution. I know it's not difficult. We can all do it. So when we say confidence interval, this is confidence interval. It's not all that difficult. Okay. So there's one thing I want us to go back to see at the large samples. So with the large samples, sometimes they will not give you the n. So when they didn't give you the n, you have to what? Make n the subject out of the formula. So we are going back to the large samples. So for the live samples, I said the formula was what? E is equal to Z of confidence times standard deviation over root of n. Sometimes they will give you the margin of error, they will not give you the n. So you have to make this n a subject out of the formula. So by making this one the subject, we what? We do cross part multiplication here. So we have this one will multiply this one. So we have E times root of n is equal to Z of confidence times standard deviation. So we are making this one a subject. So we have to what? Group items. So here by E, here by E. So this E will cancel this E. So we have root of n is equal to Z of confidence times Q over E. We want to make this n the subject, and now we have root of n. So it means we have to remove this one from here. To remove this one, we what? We multiply by half. Here too, by half. So this one will cancel this one. So in all, we have n is equal to Z confidence times standard deviation over margin of error, all squared. So let me write the formula here. The final answer here. So whenever they did not give you n, that the sample size in the question, this formula is what you use to find your n. Whenever n is not given, this is what I know I started. So this is the formula, this is the original formula, and I've break it down to make this n the subject. So I will read the question where they didn't give us the n, so that we use the formula to find the n. Okay, so I have a question here that I want to read. Okay, I'm coming, please. Okay, so this is a question here. It said you want to estimate the mean of sentences in a magazine advertisement. You want to estimate the mean number of sentences in a magazine advertisement. How many magazine advertisements must be included in the sample if you want to be 95% confident? So with the question, our confidence interval is 95% confidence. Okay. That the sample mean is within. So the sample mean is within. So we have what? Within one sentence of the population mean. Assume the sample standard deviation is what? 5.0. So the standard deviation is 5.0. So by looking at this formula, you see, let me clean this one. So the standard deviation is 5.0. And the question, we don't have any sample size in the question. So one will ask that, then where is our E? Because we don't have the E in the question. So whenever you are solving for an n, and you are reading the question and you come across within, this word within, you come across this within, the number that follows is your E. When you come across within, that the number that follows the within is your margin of error, that's your E. So here it said within 1. So within 1. So it means 1 becomes our E. So our E here is 1. So that's the clue of finding the margin of error in a question. So whenever you are reading a question and you find within, let's say within 2, within 5, when the within comes, the number that follows is your margin of error. So now we have our confidence level, we have our standard deviation, we have our E. So with the 95% confidence level, I know we've solved it already, and with the 95%, we got 1.96. So 1.90 for the confidence level of 95%. So you just do substitution in the formula. So n is equal to, this is the formula, 0 of C. The Z confidence, that 95% is what? 1.90. So 1.96 times the standard deviation, that's what? 5.0. 5.0 all over the E. So within 1, so it means our margin of error is 1. So 1. Then we put them all in a bracket, then we square them all. So you take your calculator, then you point it. So 1.96 times 5.0, then brackets, then you come down to 1. So you have to put all of them in a bracket. So we put them all in a bracket. We put them all in a bracket. We put them all in a bracket. Then we square it. So square. So this is how you point it on the calculator. Then you press equal to. So when I press equal to, I got n is equal to 96.04. 96.04. 96.04. Okay, 96.04. So you see, normally n is a sample size, and the sample size will always be a whole number, because we can't have 96.04 human beings or 96. No, it has to be a whole number. So we have to run this number to the nearest whole number. So we running or converting this answer to the nearest whole number, our n become 96, because we can't run the 0 to the 6. So this is the final answer. So whenever you are solving for n, this is the formula you use. And I'm saying that for you to detect the margin of error, when you come across redeem, the number that follows the redeem is your E. The number that follows the redeem is your E. So that's all for confidence interval. And I know we've really learned. So we solve for large samples. And for the large samples, we use the Z. The Z. We solve for the critical values. Then a situation whereby the sample size is not given in the question. That's what we just solved. And also we move on to the small samples. That's the T distribution. And I said that with the T distribution, you have to have your T table. That's your T distribution table, where we have the degrees of freedom. And to get your degrees of freedom, you subtract 1 from your sample size. Then with its corresponding confidence level given to you in the question, you find them on the table to get your critical values here. Then you just put them into the formula to get your margin of error. After getting your margin of error, then you interpret. With the interpretation, they will give you a mean in the question. So you subtract the margin of error from the mean on your on your left side. Then you add the margin of error to the mean on your right side. So with confidence interval, we always have 2 answers, the left side and the right side. I know we've really understood things, so please let's find ample time and watch. Please kindly subscribe, like, and share the videos so that we all can help ourselves. Dauda Malek, once again, is my name. Thank you very much for your time.